Hi, Revis here. In this video, I will show you how to do conversions by dimensional or unit analysis. In showing you this, I will be biased based upon how chemists prefer to do it. I will teach the concept by using examples. So here's the problem. How many feet are in 24 inches? Well, the simple math approach is pretty intuitive, right? It's 2 feet, which you get by division, because you know that 1 foot equals 12 inches. So common sense tells you that 24 divided by 12 gives you 2 for your answer. Simple math suggests that 24 inches divided by 12 inches equals 2 feet. However, as unit analysis goes, the units don't work out to equal feet. Therefore, a more proper unit math setup would look like this. 24 inches per 12 inches per feet equals 2 feet. So the goal of unit analysis then is to show you how to do that, whereby the units work out in a mathematical process to give you the units and the answer you desire. And we show you what that would look like for the problem here as a unit analysis. How many feet are in 24 inches? We would have 24 inches times 1 foot per 12 inches equals 2 feet for a unit analysis. So, for a unit analysis approach to this problem, we would set it up mathematically as shown here, which allows us to cancel out the units based upon the rules of math. So, dimensional analysis allows for mathematical elimination of units. Another thing that dimensional analysis allows for, or another way of expressing what a dimensional analysis is a process that mathematically organizes units for progression. A dimensional analysis solves problems by units and conversion factors. And that is the fundamental basis for using dimensional analysis, especially in chemistry. Dimensional analysis allows us to have an expression, a mathematical process to systematically evaluate our data based upon units. So let's look further at the components of that mathematical expression. The first component is the given. In this case, our given is 24 inches. The next part of the expression is a division crossbar, which allows for mathematically sound division. The next and perhaps most critical step is step 3. We match the units in the given to the units in the denominator. This is the most critical step in unit analysis. Whatever the units are in the given must match the units of the denominator with the units of the conversion factor. Matching the units in the first conversion factor with the given is perhaps the most important step in unit conversion. Again, taking the given units and matching it to the denominator in the very first conversion factor is critical to carrying out a very good unit analysis. We then assign the units to the top based upon standard conversion factors or values given in the original problem. We add in the specific values associated with that conversion factor. We then do the calculations and we obtain the answer. And we have confidence in this answer because the unit analysis worked out. Let's work through this problem again by looking at it in a more common fashion that you might see in math or chemistry. Again, here's the problem. How many feet are in 24 inches? We know the conversion factor of feet to inches. 1 foot equals 12 inches. The intuitive answer we know already is 2 feet. We do that by division. So here's how we work it. We set up our given and our goal. Our given is 24 inches. Our goal will have feet for its final answer. So we have our given as the very first step. Step 2 is to draw a division crossbar. Step 3 matches the units in the denominator to the units in the given. And we see that these units will mathematically cancel each other out. And I complete that conversion factor based upon its units by using known conversion factors from a table or from what's given in the problem. In this case, we have a relationship of feet to inches, which is step 4. And I complete the conversion factor by adding in the specific values. And again, in this case, 1 foot equals 12 inches. And when I do the calculations, I get 2 feet as my answer. And since we're working with exact numbers, 2 feet is the exact answer with regard to significant figures operations. Let's show you another example. How many kilometers are in 18.5 miles? If we check a standard table, we find a conversion factor of 1 kilometer equals 0.62 miles. So I write my given and my goal, and I also, for convenience in teaching this, have written out how I think through each of the steps. After you've done this a while, the steps become intuitive. So let's get to it. Here we have it. We have a given of 18.5 miles. We cross bar at step 2, and we write miles on the bottom because that is the most important step in the conversion factor to match the denominator with the given units. And then we know that we have a relationship of kilometers to miles. 1 kilometer per 0.62 miles. We calculate the numbers through, and we obtain 29.8 kilometers. We also note that the significant figures in chemistry match as well. So again, the thought process, take the given, draw a division crossbar, match the units with the denominator and the given, complete the conversion factor based upon a known relationship or a known ratio, put the values in, do the calculations. Be sure that in step 4, or the last step, we partner our units based upon our goal, based upon the solution we are after. Let's do another example, and in this case, we're going to use 2 conversion factors to get our answer. How many seconds are in 1.50 days? We know that the conversion factor is 1 day equals 24 hours. We intuitively know this, and we could perhaps do this simply by simple math. However, we want to show this by using dimensional analysis. So, 1 day equals 24 hours, and 1 hour equals 60 seconds. We have a given of 1.5 days. Our goal is seconds. We've thought through our process mentally in our preparation for doing this. Therefore, we put in the first conversion factor of 1 day per 24 hours. And we note that day must be on the bottom because that exactly matches the units of the given, which is the most critical step. We then convert the hours to seconds with a second conversion factor. Note that we use as many conversion factors as necessary to reach our solution or reach our goal. And in this case, we have 2,160 seconds. And for chemists, it matches the proper number of significant figures for reporting the answer. So this is what these problems look like when they're all cleaned up. How many kilometers are in 18.5 miles, we simply set it up 18.5 miles per 1 kilometer per 0.62 mile. We note the units, cancel out, and we get the desired solution, the desired answer. We reach our goal. Likewise, how many seconds are in 1.50 days? 1 day equals 24 hours, and 1 hour equals 60 seconds. So we have 1.5 days. We crossbar days on the bottom in the denominator to hours in the top. Then we crossbar hours on the bottom to seconds in the top. Note that the units in the bottom will cancel out with the units in the top of the expression. And we obtain our desired goal answer in seconds. So I'd now like to show you an example of what this might look like if you were doing a chemistry problem. And here it is. You're having a cookout. What quantity, mass of grams, of carbon dioxide would be released into the atmosphere for every 490 grams of propane, C3H8, used by your gas grill? In chemistry, we would write a balanced equation, which is not the goal of this video, but we point that out to you. So we would then take our given 490 grams, we would crossbar down to grams on the bottom, and in chemistry, we know that grams go to moles. We would then crossbar out the moles on the bottom and convert to new moles of carbon dioxide from the propane moles, C3H8. We would then take the CO2 moles and we will crossbar down again to 1 mole of carbon dioxide. And by chemistry rules, we know that moles are related to grams, grams per mole. We would have the moles on the bottom, grams on the top, and we reach our solution. And for chemists, the final answer must consider significant figures. This example is shown for chemists who might view this video. So there you have it, conversion of units by dimensional analysis.